Hello, everyone. Can you hear me? Hello, can you hear me? If you can hear me, please, please tell me in the chat room. Hello? Hello, can somebody hear me? Okay, thank you. Let's say the last slide today. The last slide is CloudFabric storage network solution. And this slide is almost 80%, almost 80% same as the CloudFabric Super Common Network solution. So because this two solution is focused on lossless network and the lossless technology such as PFC, NOF, and we have introduced in last week. And these two scenario, supercomputing network and storage network, they are the scenario where the lossless technology is used. So let's see the slide. We will learn the slide very quickly. So we just see some difference between super computing. Okay, let's start our slide. Okay, let's say the contents. This slide have three parts. First part is overview of storage industry development, and second is lossless network solution for distributed storage, and the third part is lossless network for centralized storage. For this part, we use NOF. Okay, let's see the first part. This is the storage industry development. We can see the data volume increased explosively, and this is from data age 2025 and sponsored by Cigarette with data from IDC Global Data Sphere and November 2018. This is all-flash drives the storage industry upgrade. We can see the latency in HDD is 2 milliseconds, but the latency in SSD is 0.02 minutes. That increased for about 100%. 100 times. Okay, and this is all-flash and distributed storage two focus. All-flash is the main driving force for centralized storage and will accelerate the storage upgrade. Second, we see here distributed storage features high scalability and ease of use as a service, efficiently meeting storage requirements of private and public cloud. And the third part, this part is hybrid storage. Hybrid storage uses different media to provide high performance flash memory and cost-effective common disk. The inventory space is still huge. Let's see some storage application scenario. First scenario, we see these two application OLAP. OLAP is online transaction processing is a transaction-oriented processing system. Generally, it's a high availability online system that mainly involves small transactions and queries, and service query processing of delicate transactions such as bank transactions, and the OLAP, the online analytical processing system is a data warehouse. So in such a system, a large amount of data is read. This is a service scenario. Key service scenario such as data analysis and data clearing. So we don't need to know more detail about what is OLTP and what is OLAP. We just know in this two scenario, we may use the lossless network, intelligent lossless network. This is a virtual desk scenario. VDI, virtual desk infrastructure, is a virtualization solution that uses virtual machine to provide and manage virtual desks. VDI hosts the desktop environment on a centralized server. You can use terminals to access the VDI over the network. Just as you use your phone, to log in our VM. This is VDI. We can see VDI requirements such as support large-scale VDI development, and a highly secure and reliable storage system is provided. Okay, need a reliable storage system. This is a intra-city storage scenario to ensure service continuity in finance, healthcare, and government sectors. Redundancy backup of multi-DC is required. So when DC is faulty, data can be quickly restored. Services are not interrupted. Service requirements can be quickly responded, and the smooth upgrade is supported. So one typical finance scenario is this is 2 cities, 3 DC. In this scenario, real-time data backup is required in the same city to prevent the key data loss. I think you may remember in the lossless technology slide, if the device is in different city, it may take a long distance. In this way, we may deploy MPCC. Or we can also deploy headroom buffer. This two technology. This is a high performance computing HPC scenario. Computing power includes basic computing. We see the computing can be divided into 3 different types. Basic computing, AI computing, and super computing and supercomputing. So last slide we learned is computing power. And HPC have the following storage requirements. HPC require independent high-performance storage to connect it to the HPC network. General purpose storage provides training data storage and general purpose service data storage for AI computing. Okay, this is this part we introduce why we need storage network, and then we learn the lossless network solution for distributed storage. This is the distributed storage architecture. We can see it have 4 different network types. First is the front-end storage network. through which application host access the storage cluster. So for the user, the front-end storage network, this part, the front-end storage network, this part is closed to user, and user for the user we usually use TCP/IP service, TCP/IP service. So the front-end storage network it may not be lossless network. The other part is back-end storage network. Transmit switching traffic of nodes in a storage cluster. It means the backup end storage network it is used to connect different storage server, and transmit switching traffic of nodes in a storage cluster. So in this slide, we most focus on the front-end storage and back-end storage. Here, this is the most important back-end storage network, and because this back-end storage network must be a lossless network. Okay, the other two types is not important. One is management network, and manages and maintains the storage system, and the BMC network provides the remote out-of-band hardware device management function. Okay, we just focus on these two types, front end and back end. Let's say the different type for distributed architecture. This picture shows the converged deployment of compute and storage node. And this is the separate development of compute and storage node. We can see the big difference is that in converged development node, application or VM and the storage node are deployed on the same server. Okay, we can see one of the cluster, this server. On this server, we have installed many app, and it can get the storage service from itself. Can see the application and the disk is in the same physical server. The other is separate deployment mode. Application of VM and storage node are deployed on different servers. We can say this is the computer node. We have 3 servers. 1, 2, 3. 1, 2, 3. On each server, we have different IPP, and the other this part, the network we call it back-end storage network, and this server 1, server 2, server 3. This 3 server is just for supporting storage service, just supporting storage service. It's called storage node. This is separate deployment. So I think from this page, you can decide what is converged deployment of compute and storage node, and what is separate deployment. Okay, let's say distributed storage traffic model. First, we see the traffic model. In the distributed storage architecture, our file is distributed to multiple servers for read and write. Acceleration and redundancy backup. When an application requests to read a file, the application concurrently access different data paths of multiple servers, and the data is aggregated to the switch at the same time. The client send a request to the server you can see the request is sent to different different node, and after the node send the traffic to the primary node, congestion may generate. This is the in-cast traffic when application writes original and backup data to multi servers. One colon n traffic is generated when application requests to read a file. The application concurrently access different data paths of multiple servers. The traffic module is n:1 in cast traffic when the data is read and aggregated to the switch. So I think you have seen this page many times. You have seen this page many times. We skip it here. This page just introduce the function of AIECN. AIECN. Okay. This is the intelligent and lossless network architecture for distributed storage. We can see this part. This part is independent distributed storage role, and the distributed storage also can be deployed in other zone. For example, in HPC zone. HPC zone. In HPC zone, the distributed storage is just used for HPC scenario, but it will be deploy the distributed storage independently. It can provide service for AI service and for HPC, and can provide for general computing. Let's say the networking architecture for storage scenario. First, we see the converged deployment of compute and storage node, and we can see we also use span and leaf architecture. Span and leaf, just as traditional data center architecture. Span and leaf, and the storage and the computing service are in the same server. And this is the separation of front end and back end storage. This is front end, and this is backup end. Backup end is just to transmit data from storage server, and this is called front end. Front end is directly provide service for the users, and this is separate deployment of nodes. We can say if they are convergence of front end and back end storage. For computing, we use this span and leaf architecture. For the storage, we also use span and leaf. And if we separation of front end and back end storage, we can see here this part is backup end for the storage, and this part is front end storage. Okay. Separate the front end and back end storage networks. This is Rocky networking. We can see here both the front end and back end all use Rocky network. The front end and the back end storage network are built on Rocky. On the front end storage network, computer nodes are connected to computer leaf nodes, and the storage nodes are connected to storage leaf node physically. The front end and the back end network are deployed independently. And this is in the front end we use TCP/IP network, and in the back end storage network we use Rocky network. That's because for the front end it's just product service for different user. So for different user, the network may not be lossless. Okay, we have stress it at the beginning of the slide. Okay. If both the front end and the back end network are built on Rocket and the performance requirement is not high, the front end and the back end network can be converted. A computer node externally provide computing service that support TCP. A computer node can be configured with two network interface cards. One provides TCP computing service and the other for Rocket to access storage service. One NIC can also be used to provide TCP computing and Rocket storage service at the same time. And during the network deployment, it is recommended that a computer node be connected to computer leaf node and the storage node can be connected to a storage leaf node. And this is the access designed for distributed storage network. The big difference between supercomputing network you can see here. Here for the storage network, the interface of the storage server can be bounded. It means it can run LACP. Run LACP with leaf, ether trunk, E trunk. Okay. This is the distributed storage scenario. Deployment solution. We just see some of them. One priority is planned for Rockaway 2 traffic on the entire network and is mapped based on the .1p and the DHCP and the DHCP packet. Packet priority. PFC is enabled on switches and the server NIC based on the priority of Rockaway 2 traffic to ensure timely back pressure in case of congestion and lossless forwarding of Rockaway 2 traffic. The PFC deadlock monitoring mechanism is enabled on each switch to prevent network breakdown caused by PFC deadlock, PFC storm, or exception spreading. This is a congestion control. We just deploy ECN, just deploy AI ECN. So this page shows the configuration of PFC. We have 3 steps. First, PFC is enabled on switches and server NIC based on the priority of Rockaway 2 traffic to ensure timely back pressure in case of congestion and lossless forwarding of Rockaway 2 traffic. This is we create a profile for PFC and we set up the priority number is 3. Second step, we configure a PFC threshold. And you can search this command in the production document. Third step, we enable PFC deadlock monitoring on each switch to prevent the network breakdown caused by PFC deadlock, PFC storm, or exception spreading. Okay, this is the page. It shows the configuration for congestion control configuration. Configure the low latency network function on leaf node and ensure automatic buffer space optimization for lossless queue, enable AI ECN, AI ECN enable. So the device will adjust the threshold itself. Okay. This is a case in financial distributed cloud storage. So this page, I think you have seen this page also many times. This is traditional Ethernet network and the CloudFabric lossless network have 20% higher performance. And last, we learned the centralized storage solution. Centralized storage solution. We also call it NOF plus or NOF. NOF. Okay. First we see the basic architecture of centralized storage. The server multipassing software. You can pass distributed read and write request from the server to the front end interface module. The centralized storage hardware consists of the following modules. First, we can see the interface module. Interface module can be divided into front-end interface module and back-end interface module. And this is the front-end. So you just remember the front-end is connected to the user, to the service user, and the back-end interface is connected to the storage itself. Okay, then it's the controller, controller mode. Each storage server have different have different number of controller. For example, this server have four controller. A controller is the core of the storage system. The controller manages storage disks. Multiple controllers are supported and work in redundancy mode. Disk enclosure. Disk module provides storage capacity for the storage system. Okay, this is the network architecture of the centralized storage network. Currently, 3 network solutions are available: FCSAN, IPSAN, and RookieSAN. And the RookieSAN is the future for the storage network. You can see the different link show the function of the link. For example, this identify the remote application in different city. Okay. Last we see the NOF solution. NOF solution. Okay, our flash drives the SCSI to NVMe. SCSI to NVMe transformation, and the NOF network is proposed. This is before, and this is nowadays. We use NVMe. NVMe over Fabric helps to develop the end-to-end NVMe protocol, thereby improving performance and reducing latency. The NVMe over Fabric have 3 types: NVMe over FC, NVMe over TCP, and in Huawei solution we use NVMe over Rookie. Okay, so this is the key point in this page. We see the advantage of CloudFabric NOF solution. We just see one of them because all the advantage you just say it's just like an advertisement. Okay. We see this part. Network-wide synchronization of single point configuration. Because the different node. You can run enough protocol. Run enough protocol. The enough protocol is encapsulated in TCP. In TCP, and you can configure reflector. Configure reflector. So all the node is the client of the reflector, and once you configure one of the configuration of the node, the switch will transmit the configuration through enough protocol. Okay, this is a far part of centralized storage network. So we just see this part. Okay. For single layer storage network, single layer, we just use leaf. If we use span and leaf, it's 2 layer. It's 2 layer. Because here we just use the leaf switch, and we have 2 plane A and plane B. This is single layer storage networking. We just use leaf node. And this is a 2 layer storage network. You can see it leaf and span. This is 2 layer. 2 layer. And this is the 3 layer storage network. You can see span, leaf, and leaf. Okay, this is the storage network. 3 layer network applicable to large network. Computer and storage node independently access the network. Each port has an independent IP address and is bounded. 2 physical plane A and B are deployed to improve network reliability. Storage nodes are deployed on independent leaf nodes to improve scalability. That's because storage nodes are deployed on independent nodes to improve scalability. You can see leaf, span, leaf. So it's called 3 layer storage network. And this is the interest replication network design. It just says traffic lines, and you see what its meaning. DCI switch needed to be deployed in the same city to implement intracity long distance lossless transmission. And plan A, and this green color, plan B, blue color, kiss the network, 100G TCP IP, all okay. Okay. This is the deployment of centralized storage. So it's almost same as the distributed network. So you can see this part, PFC and congestion control. The configuration is same with the distributed network. The end of deployment is new added. The end of feature is enabled on switch at each layer. 2 span nodes are configured as reflectors to establish connection with leaf nodes. Rows are configured as planned, and SNSD is enabled on computer and storage node. So this is a big difference. In order to make the storage node and the switch discover each other, we must enable LLDP, and we can also enable enough, and we can configure BFD for enough. Okay. I think you can already download the training material for this part. You can see it after class. This is a case for bank has deployed the two-system application, and the centralized storage server is use Huawei Dorado V6. Dorado V6. Okay, so this part it's easy to understand. Okay, this is what we introduced for the storage network. I lossless storage network. Describe the storage development trend, difference between distributed storage and centralized storage, storage application scenario, and the application and deployment of the intelligent lossless network solution in distributed and centralized storage scenario. Okay, this is all for the CloudFabric storage network solution. So if you have read this slide before our class, I think you may find it's almost same with supercomputing network. Okay, and it's just the technology using scenario of the intelligent and lossless network technology. Just some scenario for using this technology. Okay, so this is the end for today's class. So if you have no question, you can leave the meeting. You can leave the meeting, and today the class is over. Okay. If you have no question, I'll leave the meeting, and that's all for today. Okay. Thank you, everyone. We see you tomorrow.